So hello everyone, welcome to today's session. In today's session, we will be learning about the operation that will be performed on stacks using the program. Now, as you can see, this is how the program starts. Now, first, initially, we have header files. Now, here, what I have done is I have declared the size of, I've defined. Now, this is an example of a global declaration. I've declared size to be 4. Now, the reason I have declared size to be 4 is that within the code, now this is my internal loop. Now, within my local variable, this 4 is accessible throughout, and this remains constant. You cannot change this 4 when you go inside the loop. So you are bounded with just 4 variables. Okay. So here the code starts. Now I'm initializing the first variables. Now top is equals to -1. As we discussed in the algorithm, initially your top equals to -1. Now this is initialized. Reason being is, so I need top to be pointing to a null value or something which doesn't exist. Then what I have done is I have taken an array, let's say imp array of size. Okay, I haven't fixed it. I haven't fixed the size of the array. I'll be taking it from the user. Now, these are the different operations that we could perform on arrays. We have now push, pop, and show. Show is basically, it's going to display the number of elements that is present in the array. Starting off, we have the main function. This is where the main function starts. Now, int choice. Here, since I have declared 3 operations, see, push, pop, and show. Now, this will be, these are my 3 functions, basically. Now, these 3 functions will have its respective values. For example, push. I am basically using the concept of case, switch and case, okay? So based on the number of, based on the operation that you want to perform, you can enter the value. Now, for example, here push is being initialized with the value of 1. Pop is being initialized with the value of 2. And 3 is initialized with the value of, show is initialized with the value of 3. And so does end is initialized with the value of 4. See, can you see there are 4 operations which is basically performed, and this is what is really declared in the global variable of size 4. So there are 4 operations which you can perform, and these 4 are listed here. So that is why I'm declaring the size 4 here. If I want to add any other program or any other function to it, I cannot, because I have globally declared it to be 4. I cannot change it in my local declaration. But it is accessible. Global variables are accessible throughout the code. Now, while 1 means true. While it is true, you are printing. Now perform the operations on the stack. Enter your choice. Now this choice, right now, this choice is where your value is getting into, your value will be getting in. For example, now if I enter 1 here, your first function, which is push, now I can have declared push for case 1. So if I enter 1 in the keyboard, your case 1 will be activated. And what is my case 1? It is the function of push. So the compiler will understand it is the push operation which needs to be performed right now. Similarly, if I enter any other value, say 4. Now 4, I need to exit out. I have already performed all the operations. I need to come out because this switch is, again, it's kind of a loop. The switch will be keep on running until you press exit. Okay. Once you click option 4 or press 4 in your keyboard, it will understand that, okay, I need to exit the loop, exit the switch cases. So it comes out. Next, yes, when you enter 1, you move on to your push function. Now, what happens in push is, as we learned in the algorithm, void push. Now, this is the function. This is what I have declared here in the beginning, void push. Now, this is basically a function. Now, when I press 1, this function gets activated. Now, what is happening in the function? Let's see. I have declared a variable x. Now, if top is equals to size minus 1, now size is basically the size of the array. Now, if that is equal to size minus 1, this means that the stack is completely filled. There is no other space. There is no more space to add a new element. So it shows me overflow. Else, this means if this condition is not satisfied, this means there is some space available in the stack and I could add an element. So what it does is, it asks the user, okay, well, which is the element that you need to add into the stack. It takes in that element and increments the top value. First, it increments the top value. Now, initially, the top was positioning to -1. Now, when you increment it, the top will position to 0. 0 is the first index of the array of the stack. Then once you have incremented it, you are initializing or adding that variable to the position 0, 0th index. So this is where the top function ends. Now, if you have clicked on value 2, your pop operation or pop function will be activated. Now, in pop, we check if top equals to -1, our initial condition that we gave in the beginning, that we initialize top equals to -1. That indicates that the stack is completely empty. Now, if the stack is completely empty, we cannot perform any pop operation, or neither can we delete, because there is no elements present. How will I delete? So it shows the user if top is equals to -1, it tells the user it is underflow, which means there are no elements present. Next, if it is not the case, so this means that there are some elements which I can delete. So let's see the printf popped element. So obviously I will delete the element which is always on the top, because that is how it's a one way, first and last up. Okay, it's a one-way array. So I will be deleting the topmost element. So I am printing the popped element, the top element, because that is where the top would be pointing at that stage, because the last element to be added is where the top would be pointing. I am copying that element, giving it to the user, saying that this is the element which is going to be popped out, and I am reducing the size of top. So if top was pointing to index 3, now I am showing the value which is placed in index 3 to the user, saying that this element has been popped out, and I'm reducing the value of top. Now the top will be pointing to index 2 and not 3. Okay. Then, yes, if you click on value 3, if you press 3 in your keyboard, your void show would be activated. Now, what is this void show exactly? Void show is basically you are printing the elements which are present on the stack. It's basic for loop. Now, yes, here there's another condition. If there is no elements to be printed, what will you print? So again, you're checking the condition. If top equals to -1, it is underflow, which says the user there are no elements to be printed. Else, yes, for int I is equals to top, I is less than or equal to 0, I minus minus. As we discussed, it can be either I minus minus, I plus plus, I minus minus or minus minus I, based on the condition that we give. Now, here, since the reason that we are doing I minus minus is because your last element, the latest element will be placed on top. So you're traversing backward from 3 to 2 to 1, then 0. Then you're basically printing the value. Okay, understood?
Yes, sir.
So now I'll be running this code. Let's see how this works. Run. See here, my switch case runs now. So I have 4 options, which is in front of me. Push the element, pop the element, show, or end. Now let's say I'll push the element. Enter the element to be added to the stack. I would say, let's see, I need to add 10. Now, again, it is asking me to perform the operation. I would say I'll perform push again. And this time, the element that I'll perform input is 20. Now, let's say, show me the elements. So see here. The elements present in the stack are 20, 10. Now, you can change the order based on the condition that you can give. You can give a lesser sign. You can sort them. So it can show you 10, 20, or any operation that you prefer to perform. Now, I would say I would pop the elements again. See the reason, see here, now popped element is 20. Again, I'm gonna pop it. Okay, the popped element is 10. Now let's see an extreme case. Now again, I will pop. Now there is no element present, so it should give me underflow. Yes, see here. It gives me underflow. Okay, so this is how it works. And let's see what is the elements present here. So basically, again, underflow. Yep, see? Enter the choice, which I have given 3. So it shows me underflow. So there are no elements present. Now I just need to end my function. I press 4, it comes out. Done. Comes out of the switch cases.